Righto. So we've done relative frequency, which is finding out how likely something is to happen based on data that you've recorded. But there are some things that we don't need to record data on to get a bit of a handle on. Theoretical probability is where you figure out the chances of something happening without having to go and do it first. And it's the kind of thing that has inbuilt predictability to it. Like, you can see everything that's options and you can see what's going on there. Okay, so for instance, if you just have a 6-sided dice, now you know that there are 6 different options, 1 to 6. Okay, and there's only one 3. So the chances of getting a 3, if I roll a dice, is 1 out of 6. Okay, that's theoretical probability. I don't need to go and roll this dice 100 times to get an idea of how long or how hard it is to get a 3. Okay, it's just logic. It just kind of makes sense. Similarly, tossing a coin. Okay, we always toss a coin when we need a 50-50 chance between something, because you've got heads and tails. So when you toss it, you got a 50-50 chance either way. Okay, that's theoretical. We just understand that as something that's predictable. Just by looking at how something works, you can figure it out. You don't need data. Okay, so theoretical probability, you get the number of desired outcomes. So the thing that you're looking for over the number of possible outcomes. Okay, now we do this just kind of automatically, but let's just unpack it a bit. If we go back to the dice, okay, I want to know what is the probability of getting a 1. Okay, probability of getting a 1. There we go. Well, what's going on there? Okay, so how many desired outcomes are there? Well, there's only one number I want, and it's the number 1. Okay. How many possible are there? Well, there's 6 different things possible. You know, it's 1 over 6. That's it. And in fact, you could say that every single number on this dice has the same outcome, the same theoretical probability, because there's only one of each one. There is 1 5, and there's 6 options. Okay, that's theoretical probability. All right, so just a couple of things to add to that. You will be asked to find things like the sample space. So let's just unpack this idea. Sample space is simply everything that is possible. Okay, so when I roll the dice, my sample space is going to be 1, 2, 3, 4, 5, 6. That's it. That's a sample space. It's just a list of what can happen. If I've got a coin, it's even simpler. I've got heads or I've got tails. That's it. That's sample space. It's just a list of what can possibly happen. Okay, now sometimes it can be a bit of a trick to get that. Okay, and we'll look at some tricks a little bit later on. Okay, but whenever it says sample space, that's all it's looking at, is just a list of what is possible. Now, you are going to come across a question that deals with playing cards. So let's just look at that for a second. Okay, if you've never played with a standard pack of playing cards, it needs explaining. Okay, and now this will be listed for you in the test. You won't need to memorize this, but I'm just going to show you what's going on there. Okay, so there are 4 suits in a pack of cards. Okay, you've got hearts. Hearts is 1. This is hearts. You've also got spades, clubs, and diamonds. Okay, so this is what one whole suit looks like. Okay, that is one entire suit. You've got ace, king, queen, jack, and then 10 down to 2. So all up, that is 13 cards. There are 13 cards per suit. Okay, so a suit is one whole chunk like that. Within the whole deck, there are 4 suits. Okay, 4 times 13 is 52. There are 52 cards in the whole deck. Okay, so that's what we're looking at with an entire suit, but you've also got clubs. There's going to be a whole 13 of them. Diamonds, there's going to be another whole 13 of them, and spades, another whole 13 of them. Okay, so if you imagine this spread for each of these, that's your 4 suits. Okay, so what happens with the kind of questions? Okay, you could be asked, okay, so if I'm drawing a card out of a standard deck, what's the chances of getting an 8? Well, there's an 8, but there's 3 other 8s because there's 4 suits that have all the same details in them. So there's 4 out of 32, 4 out of 52. Okay, what's the chances of getting a jack? Okay, well, let's deal with that now. Okay, so we've got hearts and diamonds. All right, they are 2 suits. There's 13 in each, and they are red. Okay. Okay, then we have clubs and spades, and they are black. Okay, so it's 2 suits in each one. 13 suits each way, so there's 26 suits there, 26 cards there, 26 cards there. So that's basically the breakdown. So let's look at the kind of question that you might get. So what's the probability of a king? Any king. All right, I know there's 52 cards. There are 4 suits. Each suit has 1 king. So that's 4 over 52. Now, this is definitely where you can do the simplifying. In fact, if you don't simplify, you're going to lose marks. Okay? 4 ABC 52 is 1 out of 13. Okay, that's that one. All right. What, though, if I want 2 possible things? What if I'm drawing the cards out and I go, you know what? What's the probability of a jack or an ace? I don't mind which one I get. Okay? If you're doing that, you need to recognize that that's kind of like a plus sign. That's actually the probability of jack plus the probability of the ace. Okay? What's the probability of a jack? Well, there's 4 of them. 4 over 52. Probability of an ace. Again, there's 4 of them. 4 over 52. You can just feed this in now. 4 ABC 52 plus 4 ABC 52 is 2 out of 13. Okay. What if I want the probability of the king of hearts or any club. All right, so that's the probability of the king of hearts plus the probability of a club. All right. What's the probability of the king of hearts? Well, there's only 1 king of hearts, so that's 1 over 52. How many clubs are there? there's a whole suit of them. Any club, I don't care which club it is, there's 13 of them. Okay, so now we get the magic buttons again. Okay, 1 ABC 52 plus 13 ABC 52 is 7 over 26. Okay. Now, one more thing. What if it says this? What's the probability of not getting a heart? I want anything but a heart. Okay. Well, there's a couple of ways you can do that. You think, well, what's in there other than a heart? You can actually count up everything that's not a heart. But here's an easier way to do it. 1, subtract the probability of a heart. Probability of getting any card is 1. Okay? If I want anything but a heart, if I get the probability of a heart subtracted from 1, that works. 1 subtract, what's the probability of a heart? Well, there's 13 of them. There's 13 hearts, so it's 13 over 52. Now I just feed this in again. 1 subtract 13 ABC 52. Ooh, it's 3 over 4, 3/4. Because, think about it, a quarter of the pack is hearts. So to not get a heart means you've got 3/4 left behind. Okay, so that's something to consider. We've got this whole idea of or and not. Okay, and you definitely could get those questions. Be able to drive the fraction button on that, and that will stand you in good space. And lastly, the sample space. Remember, the whole idea of the sample space is the list of what is possible. Okay, off you go.